So guys, taking more examples to understand formation of an ordinary differential equation, we are meant to find the ODE that is corresponding to this equation. And in this equation, we have A and B, which is two constants. Therefore, we need to differentiate two times. So differentiating once, dy over dx. Differentiating once, dy over dx. If you differentiate a plus b, you're going to have b. Multiply with this, going to have b e raised to power minus 2x plus, if you differentiate this, you're going to have minus 2e raised to power minus 2x. Multiply with this. Therefore, you're going to have minus 2e raised to power minus 2x a plus bx. Therefore, dy over dx is still the same. b e raised to power minus 2x plus we multiply with minus to give us minus 2 e raised to power minus 2x a plus bx. We have this, and if we look at the equation 1, y is equals to a plus bx e raised to power minus 2x, and this is it, a plus bx e raised to power minus 2x. So we substitute this with y. Therefore, substituting it for y, you have dy over dx is equals to b e raised to power minus 2x minus 2y. Call this equation 2. Then we differentiate again because we have two constants. We have to differentiate two times. Differentiating again, we have the squared y over ds squared is equals to, differentiating this, we're going to have minus 2b e raised to power minus 2x minus, differentiating minus 2y, the constant is going to come outside, which is minus 2. Differentiating y with respect to x, we're going to have dy over dx. Therefore, we have minus 2 dy over dx. Call this equation 3. And if you look closely, we can move this minus 2 dy over dx to the other side to become plus 2 dy over dx, leaving out minus 2b raised to power minus 2x outside. Then from this equation 3, we can make this b e raised to power minus 2x the subject by moving this to the other side. Then substitute what we have here for b e raised to power minus 2x. So let's do it. We say d squared y over ds squared. Moving this to the other side to cross over, here is negative. Crossing over, you make it positive, plus 2 dy over dx is equals to minus 2b e raised to power minus 2x. Call this equation 4. Taking equation 2, which is this is equation 2. Taking equation 2, dy over dx, which is equals to b e raised to power minus 2x minus 2y. Our aim here is to make b e raised to power minus 2x the subject. To make it the subject, we're going to simply take this minus 2y to the other side. Cross over is going to be positive because here is negative. Therefore, dy over dx plus 2y is equals to b e raised to power minus 2x. Therefore, then we substitute for this. Whenever we see b e raised to power minus 2y, substitute it with this in equation 4. Therefore, substituting it, we have the squared y in equation 4. We have this is the equation 4. The squared y over ds squared plus 2 dy over dx is equals to minus 2b raised to power minus 2x. This is equation 4. This is still the same thing as the squared y over ds squared plus 2 dy over dx equals to minus 2. We are factoring out minus 2 so that we have b e raised to power minus 2x. b e raised to power minus 2x. Then we'll substitute this for b e raised to power minus 2x. Therefore, we have the squared y over ds squared plus 2 dy over dx is equals to minus 2. This b e raised to power minus 2x is the same thing as b e raised to power minus 2x here, which is equals to dy over dx plus 2y bracket dy over dx plus 2y plus 2y. This is it. So the squared y over ds squared plus 2 dy over dx minus 2 brackets dy over dx plus 2y. Opening bracket, we have the squared y over ds squared plus 2 dy over dx is equals to minus 2 times dy over dx give us minus 2 dy over dx. Minus 2 times plus 2y going to have minus 4y. Rearranging this, we're going to have the squared y over dx squared plus 2 dy over dx. This is negative. Crossing over to the other side. Crossing over to the other side is going to be positive. Plus 2 dy over dx. This is negative. Minus 4y. Crossing over to that is going to be positive. Plus 4y is equals to 0. Therefore, this plus this is going to be 4 dy over dx. Therefore, have the squared y over dx squared. 2 dy over dx plus 2 dy over dx is going to give us 4 dy over dx plus 4y, which is equals to 0. Therefore, we say this is the ordinary differential equation that is corresponding to this equation. Okay, guys, moving to example number 2, we are set to find the ordinary differential equation that is corresponding to this equation, which is y squared is equals to ax squared plus bx plus c. Here we have 3 constants, therefore we need to differentiate 3 times. So solution, y squared is equals to ax squared plus bx plus c, equation 1. Differentiating once, this y squared is the same thing as 1 times 1. I like separating it to make it easier for me to differentiate, to avoid confusion, which is very important. This is y times 1. The differential of y will give us the y over dx, multiplied by y will give us y dy over dx, plus differential of y will give us dy over dx multiplied with this y will give us y dy over dx, equals to, if you differentiate ax squared, you're going to have 2ax, because these 2 will come over to multiply everything, raised to power. This 2 minus 1 give us 1. There's still 1 here, but it's spiritual. Plus, if you differentiate bx, you're going to have b, because there is a spiritual 1 here. It's going to multiply everything raised to power. That 1 minus 1 is going to give you 0, and anything raised to power 0 is 1. So plus b. Differentiating a constant is always 0. So this is our first differentiation. Adding this up, y dy over dx plus y dy over dx, these two are the same thing, so adding them up will give us 2 dy over dx, which is equals to 2ax plus b. Call this equation 2. We need to differentiate again because we have 3 constants. Differentiating again, the squared y, differentiating again, we need to differentiate again. Differentiating again, to differentiate it, I need to separate it to make it easier for me. And this is a constant, mind you. This 2 is a constant. So when differentiation, you just remove the constant and differentiate the rest of the equation. So to differentiate, I'll bring out the constant, which is this 2, y dy over dx. Therefore, I'll have to differentiate y dy over dx. 2ax plus b. So differentiating this, I'm going to have, if you differentiate y, you're going to have dy over dx multiply with this dy over dx. This is a product rule, and y is multiplying dy over dx. So if you differentiate y, you're going to have dy over dx multiply with this dy over dx. dy over dx multiply with dy over dx. Plus, if differentiate this dy over dx, you're going to have the squared y over dx multiply y. You're going to have the squared y over dx multiplied by y, which is equals to, if you differentiate 2as, you're going to have 2a, because there's a spiritual 1 here. It's going to come and multiply everything raised to power. That 1 minus 1 is going to give you 0, and anything raised to power 0 is 1. Therefore, x is raised to power 1. Therefore, differentiating 2a is going to have 2a. Differentiating b, which is a constant, is going to have 0. Putting this well, to arrange this well, going to have 2 bracket dy over dx, 2 bracket dy over dx all squared, plus y multiplied the squared y over dx. Y multiplied by the squared y over dx squared, you're going to have y the squared y over dx, bracket close, equals to 2a. These two multiply this, we're going to have 2 dy over dx all squared, plus these two multiply this, is going to have 2y the squared y over dx squared, which is equals to 2a. If we look closely in this equation, I'm going to observe that there is 2 here, there is 2 here, and also there is 2 here. So to make it easier for us, we multiply both sides by 1 over 2. Multiplying both sides by 1 over 2, we have 1 over 2 times 2 dy over dx all squared, plus 1 over 2 times 2y the squared y over dx squared is equals to 1 over 2 times 2a. These two will cancel this, these two will cancel this, these two will cancel this. Therefore, we're going to have dy over dx all squared plus y the squared y over dx squared, which is equals to a. Dy over dx all squared plus y the squared y over dx squared, which is equals to a. Now we need to differentiate again, because we have, in the starting of this example, we have 3 constants, which is a, b, and c, and we have only differentiated twice. Therefore, we need to differentiate the third time, because we have 3 constants. So differentiating again, I like to separate this, as I said before, to make it easier for me, because this is squared. So I'll say dy over dx multiplied by dy over dx plus y the squared y over dx squared is equals to a. Differential of this multiplying with this plus differential of this multiplying with this, that's the product rule. So differential of this is the squared y over dx squared multiplied with dy over dx plus differential of this is the squared y over dx squared multiplied with this dy over dx plus this is the same, almost the same thing, this is the product rule. Y is multiplying the squared y over dx, so plus differential of y is dy over dx. Differential of y is dy over dx multiplied with the squared y over dx squared plus, what we did here is how to solve this one, this product rule. Y is multiplying the squared y over dx squared. It will be differential of y, which is dy over dx multiplied with the squared y over dx plus differential of the squared y over dx squared, which is the cube y over dx cube multiplied with y. So we have said that differential of this multiplying with it, that is differential of y is going to give us the y over dx multiplied with the squared y over dx plus the differential of the squared y over dx, which is this one, is going to be the cube y over dx cube multiplied with y. Therefore, we're going to have the squared y over dx square dy over dx. This, for this, the same thing, the squared y over dx squared dy over dx. For this plus, for this, the squared y over dx squared dy over dx. That's for this. Then plus this y the cube y over dx cube, which is now equal to, remember, all we have differentiated is this side. Differentiating a, which is a constant, is going to give us 0, is equals to 0. Then putting in this thing is the same thing with this one, the dy over the squared y over dx square multiplying with dy over dx plus the squared y over dx square multiplying with dy over dx plus the squared y over dx square multiplying with dy over dx. Since 3 of them are the same thing, going to be 1 plus 2 plus 3. It's going to be is going to be 3 d squared y over dx squared multiplying with dy over dx, because this plus this plus this will give us 3d squared y over dx squared multiplying by dy over dx, plus this, which is y the cube y over dx cube, which is equals to 0. Then rearranging in order, we're going to have y the cube y over dx cube, which is the third order differential equation, which is the highest here, plus 3 the squared y over dx squared, all multiplying with dy over dx is equals to 0. Therefore, we say that this is the ordinary differential equation that is corresponding to this equation. Therefore, we say that this is the ordinary differential equation that is corresponding to this equation.